Okay, good morning, everybody. It's 10 o'clock on the dot on my clock. Thank you very much for attending this 12th installment of the Long Coffee Break sessions. My name is Jeff McBride, and I work here at Long as one of our VRV specialists, and I primarily work with Daikin North America on the factory side of the business. Today, I'd like to introduce our regional manager with Daikin North America, Tony Faxon, to present on the evolution of the inverter compressor and to introduce Daikin North America's latest product, Daikin Fit, for multifamily that utilizes the same inverter technology. At the end of the presentation, we'll have a slide with both Tony and my contact information to take any questions that come up. Please feel free to email or call us. Also, please make sure to join us next Thursday at 10 a.m. for the next coffee break. And the topic next week is Increase Hospital Efficiency with Biocontainment Facility Solutions, presented by Jeff Rodell. So without further ado, we'll get started with Tony Faxon.
Welcome, everyone. Thank you for the opportunity to talk to you today during this short coffee break. My name is Tony Faxon. I work for Daikin North America. I've been in the commercial HVAC market for over 20 years, most of them here in Colorado. I specialized in inverter compressor and variable refrigerant systems since about 2006. Today, I'd like to discuss briefly the evolution of the inverter compressor and introduce Fit for multifamily. Historically, it's important to realize that for over a century, our industry has been monopolized by the on-off compressor system. Here in the United States, it is only in the last decade that inverter compressor systems have begun to take a foothold. That is significant when we realize that inverter compressor systems have been around for nearly 40 years. Now to review, what is an inverter? An electrical device that can change the electrical frequency being fed to a motor. So in our case, we take alternating current power, convert it over to DC power to be able to run a DC motor to our HVAC compressors. It allows us to vary not only the output of the compressor, but the output of the entire HVAC system. As this technology has evolved, it has changed how HVAC works. In this case, instead of turning on a system, waiting for it to hit set point, and then cycling the system on and off all day long, an inverter compressor allows you to perform a soft start, then ramp up to an overcapacity level to meet your set point quickly, and then slowly modulate down to meet the exact building load as it changes throughout the day. Some of the main benefits are removing the lost electrical power that occurs when an on-off motor is started and goes to locked rotor amps. With inverter compressors, there's no power spike. The unit simply ramps up to the capacity level required. Once the system nears set point, the compressor throttles down to a capacity that matches load, and the energy usage drops as well. Room temperature fluctuations are reduced even as the outdoor temperature changes throughout the day. Additional benefits are low startup amperage, no stress on windings or the compressor frame or on the piping, no more light flicker. You're pre-lubricating the bearings so that as it ramps up, instead of slamming the compressor on while all the oil is in the crankcase. This can drastically increase the compressor life, which is why a typical inverter compressor warranty is in a 10 to 12 year range instead of a 1 year commercial warranty, or if you're lucky, 5 years for residential. Inverter compressors are quieter than on-off compressor systems, and if you live in humid climates, it allows you to maintain a humidity level instead of having large up and down spikes throughout the day. The last 40 years have seen dramatic advances in inverter technology. In the beginning, it was simply cheaper and simpler to have a thermocouple turn on a relay that provided power to an on and off compressor. Inverters were bulky, the controls to properly modulate the systems were expensive. When you operate an inverter system, the controls end up picking a target pressure to meet the load. And then the controls will monitor the pressure, say every 20 seconds. And then they'll look at the delta between pressure and the actual pressure to make adjustments. The system analyzes both outdoor temperature, room temperature, and then it measures the entering and leaving refrigerant temperatures across the evaporator coil. It'll make adjustments to the system output. Inverter systems typically are mated with modulating electronic expansion valves. with oftentimes up to 2,000 steps of control, which allow the evaporator to target a specific level of subcooling or superheat. And in addition, condenser fans are oftentimes inverter driven to maintain appropriate pressures as the units modulate. Historically, there have been several events that have driven the evolution of inverter technology. For Daikin, it started in 1973 when a global oil crisis occurred. At the end of that decade, Japan passed strict energy efficiency laws due to the higher unitary costs that they were experiencing. In 1980, throughout Japan, teams of engineers were tasked with designing more efficient HVAC systems. In 1981, the first inverter compressor air conditioning unit was produced. Looks similar to this one here on my screen. In 1982, Daikin released the first variable refrigerant system. Their first RV system used stage compressors. Throughout that decade, inverter technology grew quickly, and then in 1980, Daikin released the first inverter-driven VRV system. The next 30 years has seen a worldwide evolution of inverter compressor technology. The inverter compressor has now expanded into many of the HVAC systems we see today. Here in the US, we have inverters not only being used in VRV systems and in mini and multi-splits, but many other products as well. Worldwide, the 40-year evolution has pushed inverter technology into pretty much all HVAC systems and even into residential and commercial refrigeration. FIT by Daikin is the next evolution of the inverter compressor. As we look closely at the US multifamily and residential markets, we come to the box-style conventional unitary condensing units. These units have monopolized these markets for ages, and they still produce over 5 million units a year. These units are typically loud, simple controls tied to either on-off compressors or as recently using two-stage compressors, often having a larger footprint. Now, in recent years, Daikin has brought inverter compressor technology to this style of unit, but with the release of the FIT, they are now bringing all the advantages of the horizontal suitcase style condensing unit to this market. Inverter compressors, higher efficiencies, drastically lower sound levels, smaller footprints, and a lighter weight platform. FIT comes in several platforms. You have a cooling only air conditioner, you have a heat pump, or you have dual fuel that allows you to do not only heat pump, but gas-fired heating. The initial focus for this unit has been in the 16 to 18 SEER market, which is the largest area of the US market. Oftentimes people can't afford getting into the 20 SEER, but people are trying to spend a little bit more getting away from the 13 and 14 SEER. Systems come in 1.5 to 5 ton sizes, and they have 7 incremental sizes. FIT uses the same inverter compressors as single-phase VRV systems. They can communicate with the 80 to 97% efficient furnace platforms. The DX coils come standard now with built-in modulating electronic expansion valves, and all the air handlers and the furnaces come with ECM motors with variable airflow. Probably the most important advantage with these units is sound. With inverter compressors and special acoustical fans with their own inverters, these units can get down to 55 decibels. Your typical box-style condensing units are in the high 70s to nearly 80 decibels. Now, that could be up to a 25 decibel difference. And when you consider that 3 decibels is considered twice as loud, there's a drastic advantage with going with the FIT condensing unit. Another advantage with this product is a smaller footprint and the reduced space requirements. Not only is the unit close to 1/3 of the physical footprint, but the space requirements are only 4 inches away from a wall on the coil side and 14 inches away from a wall on the fan discharge side. The more efficient fan style and the inverter-driven fan motor allow for better performance without recirculation. If we look at this 300-unit multifamily project, these benefits stand out. So with the fit condensing units, they'll occupy almost a third of the roof space as traditional box style units. And this would be without stacking them. If you were to stack them, the units would take up nearly a sixth of the space. Again, one of the benefits with suitcase style. The weight of the units would be reduced by about 35%, but more importantly, with the reduction of the dunnage on the roof, the weight savings could be over 15,000 pounds. And this is going to lead to significant savings in structural, steel, and overall construction costs. With the low sound levels of the fit, as well as the small footprint and the reduced space requirements, this opens up the doors for alternate mounting options. Not only are you you're no longer limited to roof or perimeter locations, but you can now consider balcony or deck locations as well without compromising your customer comfort. If you look at the graph here, you see the comfort levels that you get when you use an inverter compressor. The black line here shows that once it gets to the maintenance level of the scheduled set point, it varies very little compared to, as shown here, two-stage compressor systems, or what would be even worse would be a single-stage on-off compressor. These systems have a higher torque level using neodymium magnets. They have DC brushless compressor motors, which are at least 20% more efficient than conventional motors. With the advent of the Nest thermostat and its popularity, and then the drive toward smart thermostat technology, we bring to you the ONE+ smart thermostat. This thermostat utilizes a touchscreen or dial control. You have blue or red LED backlighting that shows on the wall that shows whether you're in heating or cooling mode. The smart technology with web-enabled mobile app provides geofencing, so that if you were to literally leave your facility or leave your house, the thermostat would automatically know and move into energy savings mode. The system is connected via Wi-Fi. It has two auxiliary outputs that can control, say, auxiliary heat or humidifiers. The one is capable of communicating with voice activation through Alexa and other of the speaker-controlled smart programs. Here you see the home screen that shows you the zone temperature, shows you what mode the system is, and then has the screen icons for the other screens. If you go ahead and touch the next screen, that's the adjust screen. Here on the left, you can see the zone temperature. Here on the right, you see the set points. You can either touch the screen to change set points or use the dial control. The next screen is a schedule screen that shows the upcoming set point changes, scheduled times, and has an edit mode that you can modify the schedule. Here you see an away screen that has energy saving set points that can be manually enabled or auto enabled when your mobile app reads that everyone has left the building. Here's the air quality screen that can be connected to the home air monitor that Daikin can provide, that can analyze how clean the air is coming from the indoors, can analyze how clean the air is outdoors if you're connected to a economizer or outside air damper, and can even provide weather data. Optional provisions are humidifier controls. There's specialty specialty filtration, and even UV filtration capable with the ONE thermostat. It has night and quiet modes, weather forecasting, and automatic software updates. I want to thank you for this short bit of time, and if you have any questions, please go ahead and feel free to communicate with either me or Jeff.
Thanks very much, Tony. Thank you all for attending this session. Hope you all have a great day.